What's that chunk? Oh no. Is that my pin? Yep, that's my pin. Hello Internet, my name is Quinn and this is Blondihacks. Maybe you're like me and you bought one of these letter punch sets and then got all excited to put words on things and then found out that it's almost impossible to get tidy results with these. The kerning is all over the place, the letters come out crooked, the words are all slanted, it's a mess. So I came up with a device that I think is going to help with all of that and I want to give it a shot, so let's go. So you know how this goes. You're very careful to line up all your punches. You space things out evenly, you draw a little scribe line maybe even to get everything perfectly lined up, and the result looks like this. Okay, I'm just kidding. Here's what I actually just punched, but even still, you can see how the letters are crooked and the spacing clearly isn't identical and everything's a little cattywampus. This drives me crazy. Here's what I have in mind. It's kind of a indexing jig thing, frame thing that has a little carriage that sits on top and holds the letter punches square to the work and allows you to move them in a uniform way to keep the kerning between the letters consistent. So the frame in teal keeps the punches aligned in one dimension, and then the carriage on top has these little fingers that stick down and keep the punch square in the other dimension. And then the frame has those little grooves in it that can be indexed to space the letters out evenly. Apologies to font nerds, the writing will be monospaced, but at least the kerning will be consistent. Here's a better look at what I'm calling the carriage, the little piece that rides on top. You can see that it has little tabs that ride in the main groove and then those little indexing tabs there as well. A really interesting feature about this design is that there are a whole bunch of what you might call unmachinable features. They're perfectly square inside corners, so we need a lot of square holes in things. So there's a few different ways that we can approach this. I'm going to use what I'm calling the Mr. Pete method because he demonstrated it very well in a recent video. Basically, you cut a U shape and then you make a piece that fits in that U to close up the square and then machine everything. It's a really cool method that I've been wanting to try. I'll start with the frame. I've got this really nice piece of brass that I've been itching to use for something, and it is the perfect size for this. So with the part degreased, I'll get some layout fluid on there and mark out my basic pieces here. I've got the main frame, which is going to be one piece, and then I'm going to be left with a little chunk there beside it that'll be the perfect size to fill in the square section here using the Mr. Pete method. First step is to mill out a great big U shape, and the bottom of the U is going to be the far side of the square channel. I'm going to machine the top surface flat here so we have a decent reference to start with. And then I mill out a square U shape. Because we're milling it vertically, we get nice inside corners here, dependent on the nose radius on the end mill here, but this is a very sharp-nosed end mill, so we'll get a good result here. If you were doing this on a much larger scale, you might want to rough cut out this U shape on the bandsaw, something like that, but this part isn't very big and brass is easy to cut, so it won't take long. I roughed out the shape and I left it about 10 thou small on all dimensions so that I can do a nice finishing pass on everything at once. So I'm measuring how deep I need to go, and I'm using gauge blocks to measure my width just to confirm how much to remove off of all three of these inside surfaces. And then I come back in and I do a real light 10 thou pass on the side and the bottom there at once, and then without moving anything on the spindle, I move across the bottom and then face the other side. And so everything will be on dimension, have really nice surface finishes, and be really, really square. The secret to good results with this method is that the sides there need to be very parallel to each other so that the piece that goes in fits really well, and thus when we machine the final part, the seams will disappear. And then of course we want the bottom to be very square for the final part to work well. A final check with the gauge block stack here for the final desired dimension, and that is right on. Boy, that's fantastic. Very happy with that. Okay, now we need to make the little piece that's going to go in the middle. You'll notice that I haven't machined the outside of that piece yet. In fact, the U-shape that you saw isn't even centered. Doesn't matter. What I'm doing is making basically a piece of rough stock that has the perfect square hole in the middle that I need, and then I'm going to machine it as though it was a solid piece at the end. So I squared up the top and one side in one setup, so they'll be very square. I didn't have an easy way to square both ends in one setup, so instead I'm using the bottom, what was the top, as a reference to square up the other end, and hopefully that will be close enough. So I clean up that end and I bring it down to final dimension, and precision here is important. This has to be a really good fit in the U that we machined, again, in order for the seams to disappear successfully. So that looks like it's right on, maybe a little undersized. Yeah, it's a few tenths looser than I would like, but I think it's close enough to work, so we'll give it a shot. Obviously, when I started this project, I had confirmed the sizes of all of the letter punches and made sure that they're pretty consistent, which they are. So using that, I picked a set of gauge blocks that would give me a good clearance in there for the punches. So I'll set it up, clamped up with those gauge blocks, and just verifying that the punches are a nice, easy fit in there. They need to be kind of a nice slip fit. And I checked a couple of different ones because they do vary a little bit from punch to punch, but this feels good. So now I can degrease everything, get some Loctite on the ends there. This is Loctite 603, and then clamp all of this up, and I've got it sitting on a gauge block to keep the top and bottom parallel there as best I can. Clean up the excess and let that set up for at least 20 minutes. To make sure that join is strong, I'm going to put some pins through there as well. So I don't have any small brass pins, so I'm going to make some. The scrap I have isn't very long, so I only have a small grip on it with the collet, and you can see it's got a lot of run out there. So here's an easy trick to true that up. Put a rollerblade bearing on a piece of scrap in the tool post and just bring that up until it touches. Straightens it right out. This will get it within, 5 thou, something like that, of running true, which is plenty good for setting up stock. And now I can come in and center drill that and put some tail support in there, and I'm going to turn a couple of pins out of this. It's important that these pins be the exact same material that the other thing is made out of, because if you do any kind of drilling or milling into the pins as part of the features that you're making, then it'll cause deflection in the drill or whatever if the pin isn't the same material. And it also makes sure that the pin disappears after all the surfaces are machined. I'm checking to make sure in multiple places here that I'm right on dimension. These pins are going to go into reamed holes and they need to be a really good fit. And we are there. So now I can set this up vertically in the vise, and I'm just squaring it up with a little square here that's precise enough for this. Doesn't matter if the pins aren't super straight because no one will ever see them if we do our job right. And I marked a position that's biased to one side. It's not centered on the stock because, of course, a lot of the stock is going to get machined away. And I want the pins to be centered on the final part, not on what we have now. So I drilled and reamed a nice deep hole all the way through both parts here. And again, the clamp is still on there and the Loctite is in there to make sure nothing moves while we do this. Do a little test fit with one of my pins here, and that's an excellent fit. Exactly what I want. There's actually some air pressure in there, which is good. There should be for a good fit like this. So that will work. I can clean out that hole now and then clean up the pin, degrease everything, get some Loctite 603 on there, and get my pin pressed down in there, and then once again let that cure up. You can see there's air pressure effects wanting to push that pin out, so I kind of pushed it in and kind of forced the air out, and you can see the Loctite squeezing out the seam there a little bit as well, but finally got the air out and it's stuck down in there, so let that cure, and now we can machine everything flat. I left the pins extra long because I wasn't sure how deep I was going to drill. And once those are milled down, then I can mill the top flat here. And if we did everything right, then those pins will completely disappear because they're in a reamed hole, nothing is chamfered, and they are the exact same material that we pressed them into. From this point on, my reference is the center square hole there. So all of my dimensions are going to come from here. A little deburring, you can see how that pin has completely disappeared. No sign of it being in there at all, which is perfect. So then I flipped it over and did the same thing on the other side. Now I have what amounts to a piece of rough stock with a perfect rectangular hole in the middle of it. So now I'm going to square it up as though I was starting fresh with a new part. And once again, as I machine the surfaces that have the seams in them, again, if we did our job right, those seams will disappear. If you're really paying attention, you may have noticed that I'm machining the sides here in kind of a random order, not the proper sequence that you should do for squaring up stock, but that's fine. I'm doing it in the order that's most convenient for the type of part that I have here, and ultimate squareness of the outside of this thing really isn't that important. To the top surface now, I have some fun stuff to do here. I'm going to clean up the top with the fly cutter because I just have a very light surfacing that needs to happen here. Really no material removal to speak of, and the fly cutter is going to do a great job here, I think, finish-wise. Plus, it's a great excuse to use this mass-balanced parallelogram fly cutter that I built in a video series a while back, so go check that out if you're interested. Once again, as the fly cutter moves across, you see those seams disappear just like magic. This is super satisfying when it works. Now, down here at the other end, it was a little less successful. You can still see a little bit of the seam, but at a glance, I'm super happy with that result. And being a fly cutter, the finish is outstanding. Next, I picked up this very special end mill. This is a 1/16 end mill. Oh my gosh, it's so tiny. And I needed it for cutting the slots. Now, an end mill like this needs to be run balls out fast. And so I'm gonna have to move the belt on my mill, which I've never actually done before. So that was an interesting little exercise. Let's see how fast this thing will go now. And it tops out at 2,500 RPM, which is not bad. It's about a fifth of how fast the book says an end mill like this should be running, but it's the best I can do, so we'll give it a shot. To cut the grooves, I'm going to use the linear drilling function on my DRO. It's intended for rows of holes, but really you can use it for any linear pattern of features. So I'm just doing a sanity check at the far end there to make sure it's going to land where I expect, and it does. So I can go and mill the first slot. And then I hit up arrow, it tells me how to get to the second slot, and I proceed. So I'm just looking at the x-axis on the DRO there and just ignoring the y. It doesn't really matter. I'm just using it as a linear pattern generator effectively. And that worked really well. Now that was one pass. I need 3 passes to get to my final depth. So I can just loop back around and go back to 1 and do another pass. Now you could go back and forth counting down from 15, but I like to do it in the same order each time so that my mental routine doesn't introduce mistakes. This tiny little end mill did great, and even though I was running it too slow, it cut very well. This is the smallest end mill I've ever used, but of course the watchmakers out there are all wondering where I got that big facing mill, and also how did I get my mill to run so slowly? And now with this 2-flute carbide chamfering mill, because chamfers are what separate us from the animals. Here's where I'm at so far. I really found that Mr. Pete method worked really well. You can, as I said, see the seam a little bit at one end, but at the other end it worked really well, and that's just down to how well or not well I executed at both ends there. But shiny side down, time to machine the underside. I just have to carve out a big area here in the middle to create the feet. And I also skimmed the bottoms of each foot just a couple of thou to make sure that they're all flat and in the same plane there. Now, a late addition to the design, I'm putting a little pocket in the bottom of each foot to hold a magnet. This was actually a suggestion by one of my patrons. They got an advanced look at this project, and that seemed like a kind of a good idea. If the frame is going to be sitting on something ferrous, then maybe the magnets will hold it in place. I'll give it a shot. I did find I needed to draw file the final slot a little bit. I cut it a little close on the dimension with my punches, and these punches actually also needed some deburring. You can see the raised lettering had some burrs, and then they all had this kind of tab on the back here, something to do with how they're made, I'm sure. So they all needed a bit of stoning to get them to be consistent in size. On to the carriage now on top. I've got some 303 stainless that I thought would be fun to make this out of, and I also found some precision ground stainless round bar to make the pins out of, because I'm once again going to need a square hole, and I'm going to use the Mr. Pete method here once again. Now, because this is just a single square hole, you could also just broach this, and honestly I could have broached the frame as well, either just at each end and then mill in between, or do a series of broaches, something like that. But I don't know if you've priced out square broaches lately. They are very, very expensive, and yes, I know ClickSpring made a brooch. We've all seen all of his videos. But the Mr. Pete method here is a great option for those of us who can't afford brooches and don't have the skills to make our own. Having learned my lesson with the inconsistencies in these punches, I'm test fitting them now before I close up the square. The H punch here was the worst offender, and that fits okay, but I did open it up a couple more thou. Now I'm using gauge blocks to figure out exactly how big that slot is, and then I machined the piece to go inside it. This one I cut a little bit closer than the brass, so I made it kind of a snug fit in there. And then I again got the Loctite on there, and I'm using the punch itself as the spacer this time because the hole's too small for my gauge blocks. I put a shim in there to make sure there's clearance for the punches to move. And then as before, I'm drilling and reaming this to put a pin all the way through. I had one close call here with the reamer. It got bogged down in there and threatened to start work hardening the stainless, but I got lucky and was able to push it through at the last second. Almost broke the reamer in there, I think. But once again, the pin is Loctited in place, and now I can machine everything, and as before, the pin disappears, as do the lines between the pieces here if we do our job right. Now I should be able to pull that shim out of there. Well, I guess it got a little tight in there. A little percussive persuasion, and out comes that punch. And as before, we've now got effectively a piece of rough stock with a nice square hole in it. And once again, I'm going to fly cut the top surface. I've never fly cut stainless before, so it'll be interesting to see how this goes. I'm using anchor lube, by the way, on all these stainless operations. That's the green toothpaste that you see. And well, this just in, fly cut stainless might be my new favorite thing because that is amazing. Once again, I chamfered the edges, and take a look at that. That finish is just incredible. Wow, stainless fly cuts really, really nicely. I had no idea. You can see the seams there when the light hits it just right, but overall, really happy with how this part turned out so far. Flip it over again to the bottom, and once again, I'm using the square hole in the center as my reference for the rest of these operations. And so I have a bunch of work to do here. I need to make all those little tabs on the bottom. It was kind of fun to plan out the order of operations here because these tabs all kind of interact with each other in different dimensions. So I milled away the sides all the way down to the bottom plane there. That was an easy way to start. Then I machined the ends of the larger tabs down to the Z height of the top surfaces of the smaller tabs. Now recall that I carefully put the pin off center in the part that was going to remain after all this machining, and well, as you may have deduced from my cold open, I lost track of which side was the top on the stainless part here, and I machined right through the pin that I had so carefully placed in the unmachined area. So now there's just Loctite holding that little piece in there, but the Loctite is very strong and there's no real force on this part, so I think it's still going to be fine. One quick swipe through the middle there to get rid of the remnants where the burrs couldn't quite break off. Now I can test fit and make sure I got those larger tabs the right width, and they are good. It's a nice, easy sliding fit in there. And then I was able to come in with a small end mill that was the size of the gap between the big tab and the small tab there. So I was able to finish out the sides of the small tabs by sneaking in between there like that. And then I just had to use this same small end mill because it was on there and it was already at the exact right height to do a little cleanup in all of the corners here. There's the final result. Everything looks good. It's all very furry because of the stainless, so I had to spend a fair bit of time deburring here with a needle file. I want to deburr the part in situ so that if I have to make any adjustments anywhere dimension-wise, I can do that, and I haven't lost my DRO references. Got that mostly cleaned up so I can do a test fit with the frame, and yeah, that fits on there really well. So it's a little snug, but I can tell we're within deburring range of having the fit that I want. Here's all the little features on the underside of the carriage, all cleaned up. You can see the tool marks there, of course, on the stainless, and you can really see how, in comparison, the fly cutter really shines, so to speak. Now, in go the little magnets with some Loctite. And here's the final result. I'm certainly pleased with how it looks. Let's see if it actually functions as I hope it would. This is, after all, just a prototype of an idea. So I've got a piece of scrap aluminum here that I'll try punching. I've got a spring clamp there to hold the system in place. And let's do some punching. So I punch the first letter, then I move the little carriage over one notch, put in the next letter, and so on. And that's the result. It's pretty good. The letter spacing's nice and even, but the letters kind of drifted uphill there at the end. I think what's happening is the hammering is causing the frame to shift. So more substantial clamping for the second attempt here. I really like how the punches feel. They stand up very straight and they stay perfectly in place when you hit them with the hammer. It's working really well. And the carriage is very satisfying to move from slot to slot. So with the improved clamping, the result is excellent. Letters are perfectly spaced. Everything is perfectly straight within the variance that's in the punches themselves. Like the Q is a little high, of course, because it has a descender on it, and so it's going to be a little higher than the other letters. And then there's a little bit of variation that's down to how hard you hit the punches, so the impressions aren't all identical, but overall, this is night and day better than what happens when I normally try to use these letter punch sets. So there's the final little device. I had a lot of fun making this, and I hope you enjoyed seeing me try out the Mr. Pete method for creating those so-called unmachinable internal square features. As always, if you want drawings and 3D models for this project, you can find them on my Patreon. Thank you very much for watching, and I will see you next time.